Hi guys, welcome back to my channel. My name is Chidi. In this episode, we'll be building the brain of our model, which is the architecture. Previously in episode 1, we have collected and organized our data sets. We got our data from Kaggle. In episode 2, we cleaned and prepared the data set using resizing, normalization, and powerful data augmentation tools. Now, in this episode 3, it's time for us to build our architecture, which is the brain of our neural network. You can think of this architecture as a pipeline that every image must pass through. For example, it's like giving each image a digital passport. Like we extract each important features, like flatten them, then we send it to make decision. So we extract our features using this conv2d layer, then we do MaxPooling, then we do flatten, then we make our decisions. The first thing we need while defining our architecture is for us to import. So we make our import, which is these first 2 lines of code, as you can see. From TensorFlow.keras, import this, then you import conv2d master. So after you've done your importing, the next thing you do is to specify your model. By writing model equal to sequential, then you open this bracket. Inside this bracket is where you specify your architecture. If you want to have a very simple model, like just a 1-block model, where you have just a conv2d layer, a MaxPooling as 1 block, then you have 1 fully connected layer, which can include flatten, dense, or whatsoever. So you can also specify inside this bracket, you can specify more than 1 block. If you want 3 blocks for your architecture to be a bit complex, or maybe for your programming to be a bit perfect, you need more than 1 block. What I mean by 1 block is just a simple block that have conv2d and MaxPooling. I will explain this carefully, but you see this is a 3-block model because it has conv2d MaxPooling in the first block. So the system goes back to do the same thing again by incrementing to 64, as you can see. So in block 2, we have conv2d, we have MaxPooling, but if you check carefully, you see that there are some variables that are increasing. In the first block, it was 32, now it's 64. So in the third block, we have 128. So it's like you are doing it over and over 3 times for what we are making our model to be perfect. This is the first block, the second block, the third block. Then we specify our fully connected layers, which include flatten, dense, dropout, and our output layer for us to bring out the output of our projects. As you can see, in our first block, we specify the number of filters as 32, our filter size as 3 by 3. Our activation, we use ReLU. You can use TAN, you can use Sigmoid, or you can use ReLU. And we specified our input image dimensions as 150, 153. All these are specifications which can vary. They are not fixed, but it's worthy of note that these are required for us to be able to specify our block. So to specify a block, first thing you do is you write conv2d, you open your bracket, is the bracket which you close. Inside the bracket, you specify first input is number of filter, the second one is the filter size, the third one is activation, and lastly, you specify your input image dimensions. Once you've done this, you've completed or you perfectly defined a block. So after defining a block, the next thing you do is what we call MaxPooling. MaxPooling is very important. Let me show you back in our previous MaxPooling. You can see MaxPooling. We did MaxPooling here. MaxPooling 2D 2,2. It is very important. Why do we do MaxPooling? It's optional, but it's highly recommended for downsampling. Because if MaxPooling is applied after each block, it will help us to reduce the spatial dimensions, making our network become very, very fast, and it will help us, and it will help you to focus on the most important features. So it's like a recommendation while specifying your architecture that once you specify your first block, the next thing you must do is MaxPooling. Then even if you specify another block, you must go back to MaxPooling, because without this MaxPooling, So now that we've completed our first block by doing our Conv2D and also doing our MaxPooling, the next thing we need in our project is to flatten it out. We flatten out because this is typically needed before our dense layer. If you don't flatten out, there will be a mismatch in shape and there will be errors. So it's highly recommended that we use this flattening after specifying our Conv2D and MaxPooling before we get to our output, which is our dense layer. So now that we'll flatten out, the next thing we'll be specifying is this line of code, which is the output layer. Without this, our model cannot make final decisions or classification based on the features which is extracted from the beginning. So if we don't specify this, after specifying all other layers from the beginning, like the Conv2D, the MaxPooling, the flatten out, without this, our model cannot make final decisions, and our CNN will become somehow not connected. So what we do is that by specifying this, your model becomes fully connected, and it will allow the network to make decisions without every of the layers connected. You can see that this is what makes the model to make its final decisions. Now we have another architecture with a 3-block. Like I said initially, we've specified the import. We've done our imports. So we write our model, which is a line of code, which inside it we have maybe 1 block and fully connected layer. But in this case, we have 3 blocks. This is the first block, the second block, the third block, and we have a fully connected layer. What does the fully connected layer do? The fully connected layer flattens what we've gotten from our block. It uses, then it brings out the output. So I'll teach you in the next video why we hit a dropout here. So in summary, each image from our data sets, for example, you can see this cat image. Let's say I got it from my data sets of images, has to go through this process of this stage 3, which is what our architecture. So now that we've defined our architecture, each of the image will pass through this process, knowing fully that the original image, what the system sees or the program sees, that this image starts as pixels. Our eyes can see this as image, but the system sees this as pixels. For example, 150 by 150 by 3, which is for like RGB. This is just like a raw number, pixel values. So when we specify our Conv2D, specify number of filters and the rest of the data which we specify, this layer is what helps it to scan the image with the filter which we've already specified. Let's say 3 by 3. It will scan it, then extracts low and high level features. For example, we extract like block, if our block 1 is like edges and texture, as block 2 we specify like, okay, it should check corners and shape, and in our third block you specify object like, or that's how we use more blocks, because if you use only 1 block, the first time it goes through it might just extract just the edges and the shapes, the corners, the shapes, the textures, other things that the object like regions might not be extracted, so our operation might not be that accurate. So that's why it's good to specify more than 1 block. So when you specify this Conv2D the first time, specify it again the next time, the third time, the computer will be able to get, the program will be able to get every details which is needed for perfect prediction. So once you specify that's your block, the next thing we specify is the MaxPooling, which is, just think of it like, okay, summarizing the features and reading data. So after each of the block, there must be a MaxPooling, because what comes out of this is a bit scattered. So once we present the MaxPooling, it helps to summarize the features and reduce the data. So after the MaxPooling, what we have to do is flatten. We flatten like, okay, there's a coil, and now we want to flatten that to make it flatter. Let's say it takes the 2D feature maps, like, okay, let's say, and it now unroll them into a 1D vector. It's like, let's say, turning all the data features into one long list of numbers, making it better. So the last thing which we do is what? This dense. Specify this dense layer. So why do we specify this? Let's think of this dense like, think of it like a decision maker. Yes, what makes our decisions? What comes out of this flattening enter to a dense layer, and now we get decision. It doesn't see the original image. What it sees is like a list of smartly extracted features from earlier layers. This sees smartly extracted features from this being flattened, then it sees it. These features represent like edges, shape, pattern that helps the network to make final predictions. So like at this level, we can now say, okay, the program can now decide like this a cat or this a dog based on the feature which it has extracted, the shapes, the patterns. So the dense layer is like putting everything together and making final decisions. Thank you guys for watching. I hope you enjoyed this video. In our next video, we will train our model.